Okay, grade 12 pre-cal, lesson 7.6, double angle identities. So these are more on your formula sheet. So if you have your formula sheet, make sure you always have it with you. These are the ones down the bottom here. Sine to alpha, cosine. Wow, there's 3 cosine ones because you can use different ones, and then there's 1 tan. So sine and tan are really easy because you only have one formula to pick from. But cosine, you have 3, and all 3 will work depending on what you have. Okay, so let's look here. So example number 1, evaluate tan 2 pi over 3 using the double angle identity and setting theta equal to pi over 3. So what we want is we want to use the tan to alpha one or tan to theta, right? Depending on what you use. If it says alpha, use alpha. If there's a theta here, use theta. Keep your things consistent. So there's the formula right there. 2 tan theta over 1 minus tan squared theta. Okay. Well, we're going to plug in tan 2 pi over 3. Well, that's just 2 times pi over 3, so 2 pi over 3. 2 pi over 3. Can we find that? Yeah, it's on the unit circle. So then we can replace it here. So we're just doing the work here. So 2 tan pi over 3, 1 minus tan squared pi over 3. Pi over 3, is it on there? Yep. Right, you can do the work here. I see I did the work over on the side. Root of 3 over 2 divided by 1/2, multiplied by the reciprocal, you end up with root of 3. Okay? So we can replace these pi over 3's with root of 3, root of 3. There it is. Can we do the math? Yeah. 2 times root of 3 is just 2 root of 3. Root of 3 squared, right? It's 3, so 1 minus 3, negative 2. What do these 2's do? They reduce down. Careful where that negative is, right? So it's negative pi over 3. So it's just a matter of taking whatever they give you and picking the right formula and plugging it in. You really have to have your unit circle in front of you to do this so you can find out the numbers really, really quick. Okay, let's go to example number 2. If sine theta is 4 over 5 and cosine theta is 3 over 5, determine these two things, sine 2 theta and cosine 2 theta. Okay, so let's grab a formula. So sine 2 theta, there's the formula. We know what sine and cosine are, so just plug them in. Just multiply straight across, right? 2 over 1, 4 over 5, 3 over 5, 24 over 5. Really not that difficult, right? It's a matter of getting the right formula. What about cosine, though? Well, you can pick any formula. I happen to pick 1 minus 2 sine squared theta. Works. So plug in the numbers. So the sine, we're going to plug in the 4 over 5, square it, times it by 2. We have 1 minus 32 over 25. You got to find common denominators. 1 can be written as 25 over 25. And you can write anything like that. Subtract, we end up with negative 7 over 25. Right? Really not that difficult. Once they give you the sine and the cosine, you can just plug them in using the formula. This will work, this cosine one, if you pick the other 2 formulas. If you don't believe me, give it a shot and try. All right, example number 3. Got a proof. Proofs are so common. Cosecant 2x minus cotangent 2x equals tan x, right? So now we're using x instead of thetas, right? Switches back and forth, but if you see it's x's up here, use x's in your example then. Don't switch it to x from x's to thetas. Keep it consistent. So what side are we going to work? Well, tan is really easy because tan is just sine over cosine. So somehow over here, we got to change this to get a sine on the top and a cosine on the bottom. Well, let's get rid of cosecant. So cosecant is 1 over sine. We know that. The 2x just goes with it like it normally goes. Cotangent 2x is just cosine 2x over sine x. Okay, that works. Now, if you look, do we have common denominators? Yes, we do. So we can take and just combine the numerator together. So 1 minus cos 2x. There it is. Oh, look at this. Hey. Cos 2x can be rewritten as 2 sine squared x. Where did I get that from? That's just from your formula sheet, right? You can get it from your formula sheet. It's right there. So we can replace that whole cos 2x with this right here. So we end up with replacing that 1 minus 2 sine squared x, right? It's just from the formula sheet. Well, what do we do with this? Yeah. We do the rearrangement on this. We end up with 2 sine squared x on the top. Where did we get this from the bottom? This 2 sine x cosine x. Well, that was just changing sine 2x into it. So then we end up with 2 sine x cosine x. Now, if you look, this is all multiplication down the bottom here. So we can reduce stuff. So we can take the 2's out. And we got a sine x here, and we have 2 of them up there. We can get rid of one of those. So we end up with just sine x over cosine x. And that's what we were looking for here, right? Oop, I didn't want to do that. I wanted to highlight that. So that's what we end up here with sine x over cosine x. Sorry, sine x, yeah, and sine x over cosine x down here. The proofs are a little trickier. Really, it's you have to figure out, where am I going to go with this one? So when you look at the original, I mean, you could have tried to take this 10 and rearrange it to this more complex thing, but it's often easier to take the more complex one and reduce it down to something simple. Okay, now the last 2 pages here are examples from the exercises that you have to do. So this is exercise 7.6. So let's look at question number 1C, because these are common ones that people have problems with. So that's why I put them in the notes. So what we have here is cosine squared pi over 3 minus sine squared pi over 3. Well, if you look, that cosine squared minus sine squared can be written as cosine 2 pi over 3, right? We can use our double angle identities and go backwards. So it simplifies this quite a bit, because then we end up with cosine 2 times pi over 3. Well, cosine, well, what's 2 times pi over 3? Well, 2 pi over 3. Now, can we find the cosine of 2 pi over 3? Yeah, just grab it off your unit circle. It's negative a half. So what we did is we went from something a little more complex down to double angle identities to make it a little more simplified. Okay, 7C. Proof. We got a good old proof. So we got a cotangent and a sine and a 1 over 1 minus cosine. Oh, sorry, sine 2 over 1 minus cosine squared. What are you going to work? Well, I'd work the right-hand side. It's more complex. So this one, this cotangent, we just broke it down to 2 cos over sine. Remember, cotangent is cos over sine. Well, let's see what we got here. So what are we going to do? Well, we're going to take the bottom, and we're going to, hey, that looks familiar. That's not a double angle identity. That's a Pythagorean identity. So if you look back, remember? So now we can start mixing stuff. So we're looking here. Oh, yeah, there it is right there. We're going to use that one. Okay, so that's what it is. Remember, you can rearrange these things. So sine squared theta equals 1 minus cos squared theta. Oh, yeah, that's the one we want. So we can replace this whole bottom with sine squared theta. There it is right there. Awesome. Okay, what about the top? Well, sine 2 theta can be broken down. There's only the one sine there, right? We can look at our sheet again. There it is there. Yeah, nice. So we break it down to that. What about the bottom? Sine squared theta just means sine theta times sine theta. So we break the top down, break the bottom down. Now look, these are all multiplied on the top. These are all multiplied on the bottom here. We can get rid of one of those sine thetas. So we end up with 2 cos theta over sine theta. Yep, there it is. That's what we're looking for. Again, try to work through the harder side and try to simplify it down. Okay, last page here. I think we have question number 4. There's 3 parts to this, A, B, and C. Kind of a big question. So what they give you is they give you the tan is negative 2 over 5. Well, where's tan negative? Tan is negative in quadrant 2 and 4, but it's negative 2 over 5. So what has to happen here? Well, I think in the question it tells you that. So tan is opposite over adjacent, or y over x. So we can break it down. Now, if we notice here, the y has to be positive because it's in quadrant 2, but the x has to be negative. Okay, that's great. Well, we need to know what r is. We need to know what the hypotenuse is. How do we find that? Well, Pythagorean theorem, right? So you could use it as a, b, and c if you wanted to. You can use it as r, x, and y. You can use it in any form you want as long as you keep the pattern there. So we have 2 shorter sides. We're finding the longer, so we're going to square them and add them. Okay, so we end up with root of 29. Are you going to change that to a decimal? No, because everything has to be exact value, so we want to leave it as root of 29. So we know what the tangent is, negative 2 over 5. Let's find the sine. The sine is opposite over hypotenuse, so 2 over root of 29. Cosine, hey, careful, that's negative, so negative 5 over root of 29. Well, now what we can do is we can use that to answer a bunch of questions. We can add sine 2 theta, cosine 2 theta, and tan 2 theta. So sine 2 theta, there's our formula, double angle identity. We just plug in, right, sine and cosine. Math is quite easy because the root of 29 times the root of 29 works out really nice. We end up with negative 20 over 29. Math is not that hard. Cosine, again, you can pick any one. I just happen to pick this one. So 2 cos squared theta minus 1. We replace cos with negative 5 over root of 29. We're going to square that. That's pretty easy. Negative times a negative, positive. 5 times 5, 25. Root of 29 times root of 29 is 29. Multiply by 2. We end up with 50 over 29. Well, where did this 29 over 29 come from? Well, 1 can be changed to that, right? We're trying to find a common denominator so we can subtract. Then we do the math, 21 over 29. What about tangent? Ooh, pretty complex. Look at this. Sine over 2 theta, cosine 2 theta. Well, we know both of those because we just calculated them above, didn't we? Oh, look at that. Yeah, we calculated them right there. So we can actually plug them in that way. So since we did sine and cosine, shortens it up and does all the math for us pretty easy. Now, could you change it to this formula over here? Yeah, it would still also work, but there's a little more calculations in there. Okay, So because we did sine and cosine, we can do the last one pretty easy. Now you got to be careful with something like that, because what if you made a mistake back here in sine and cosine? Well, guess what? If you do use those numbers down here, there's going to be a mistake in it also. So be careful as you're going through and really double check your answers before you move on. All right? That's the last lesson there.